Here's a question where a lot of the difficulty is understanding what the question is asking. It's a number 14 out of 25, simulating an AMC 10. You bought a large bag of mixed raisins and peanuts, which is 1/3 raisins and 2/3 peanuts. These are quite common in the United States, as they are sometimes called trail mix, which is what you would eat if you go hiking. Every day you pour out 1 cup of the mix into a bowl. But you love peanuts, and by the end of each day you always eat all of the peanuts in the bowl, as well as 1/3 of all of the raisins which are in the bowl. If the bowl starts empty before you pour the mix on the first day, on which day does the bowl contain more than 4/7 raisins immediately after you pour out 1 cup of the mix? The meaning here is that I want to know when, after you pour the 1 cup of the mix in, it is 4/7 raisins. Understanding the question is one of the hard parts. And if you see, by the end of every day, at the end of every day, there are only raisins in the bowl. No peanuts at all, because you have eaten all of them. And then at the beginning of every day, you add more raisins and more peanuts, but at the end, again, only raisins. So now, maybe the way to think about this is to try to see how much raisin is there every day. Because you already see that the peanuts are not very important. Only the raisins will stay. So, right after you pour, on day 1, immediately after you pour, you have 1/3 cup of raisins. Now what happens? During day 1, you eat 1/3 of the raisins. Remember, I don't have to care about the peanuts anymore because those always get eaten. So by the end of day 1, I will have eaten 1/3 of the 1/3 cup raisins. So how much will be left will be 2/3. At the end of day 1, I'll have eaten 1/3 of that. So at the end of day 1, the amount remaining will be 1/3 times 2/3 cup of raisins. I'm choosing to do a multiplication because that will be easier than adding and subtracting. I'll have to do enough adding and subtracting by the time I'm done with this question. Now day 2 starts, and at the beginning of day 2, an additional 1/3 cup of raisins is added. So now I have 1/3 times 2/3 plus 1/3 cup of raisins. What will happen at the end of day 2? At the end of day 2, I will eat 1/3 of all of this. So at the end of day 2, I will have left 2/3 times 1/3 times 2/3 plus 1/3. Okay, and it will continue and continue in this way. I want to simplify the end of day 2 because I'm looking for a pattern. This question looks like one which is very, very complicated. So to look for the pattern here I see this is 1/3 times 2/3 times 2/3 plus 1/3 times 2/3. Interesting. So at the end of day 1, 1/3 times 2/3. End of day 2, 1/3 times 2/3 times 2/3 plus 1/3 times 2/3. Day 1 at the beginning after I pour, 1/3. Day 2 at the beginning after I pour, 1/3 times 2/3 plus 1/3. At the beginning of day 3 after I pour, it's going to be 1/3 plus this plus this. So I actually already see a pattern. You see, after I pour on a day, at the end of a particular day, I will have a certain number of terms. And so, right after I pour on the day n, the amount of raisins that I have will be 1/3 plus 1/3 times 2/3 plus 1/3 times 2/3 squared plus ... plus 1/3 times 2/3 to some power. What will that power be? Well, over here, if I was at day 2, I have 2 terms. Day n, I'll have n terms. If I start with 2/3 to the power 0, here it will be 2/3 to the power n minus 1. This is actually a geometric series. And what that tells us is that we are just wondering, when does this geometric series reach a certain value? Let's return to the problem to remember what it's talking about. We want to know on which day it contains more than 4/7 raisins immediately after you pour out 1 cup of the mix. Well, over here, remember that immediately after you pour out 1 cup of the mix, you are going to have 2/3 cup of peanuts. And we want that the raisins are 4/7 of the mix at that time. This is telling me how much raisin I'm looking for in order to finish the problem. You see, I want the 2/3 cup of peanuts to be the 3 out of 4 on this ratio, because this ratio is 4/7 raisins, which means there should be 3 parts of peanuts, and 4 parts of raisins. And so if I do that fraction, I want 4/3 times 2/3, and I get a number which is 4/3 times 2/3 is 8/9 cup of raisins. Okay, so this is exactly what will give me 4/7 raisins. I want to know, when do I get to 8/9 cup of raisins? Let's go back to our geometric series, which we were looking at. I want to know, when does this thing meet 8/9? When does this thing pass 8/9? To make the problem easier, I see a lot of 1/3 everywhere. That will be at exactly the same time as when a different series passes 3/9. I'll multiply both top and bottom by 3. So that's the same as when the series 1 plus 2/3 plus 2/3 squared plus all the way to 2/3 to the n minus 1. When does this pass 8/3? Okay, now at this point, I need to actually have a formula for the sum of a geometric series. You may already know this. I'm just going to very briefly review this in case you don't quite remember. The way to do this, if I'm adding up, I'll do a simple review if the geometric series starts with 1. Let's review the sum of the geometric series. If a geometric series is 1 plus x squared all the way to x to the power n minus 1, the easiest way to come up with this formula is to call this x, multiply both sides by x, and I'll have now x plus x squared plus all the way to x to the power n. And so if I subtract the two equations, if I take this one minus that one, then I get 1 minus x times s is equal to, all of the intermediate terms cancel, 1 minus x to the power n, and so s equals 1 minus x to the power n over 1 minus x. So now let's go and use this on the problem. Here my x is 2/3. If my x is 2/3, then this becomes 1 minus 2/3 to the power n divided by 1 minus 2/3, which is 1/3, and it's in the bottom. So if I flip it up, this becomes 3 times 1 minus 2/3 to the power n. Now I'm asking, when does this pass 8/3? Okay, I have an extra 3 here. I'm almost done, actually. When this thing passes 8/3, I can now start to compare them. I can divide both sides by 3. And if I divide both sides by 3, what I'll find is I need to know when 1 minus 2/3 to the power n passes not 8/3, but 8/9, which is also when 2/3 to the power n passes 1/9. And what I mean here is, in this first pass, what I mean is that it's bigger than. Here, I'm asking when it becomes less than, because I have a minus sign. Well, at this point, now I just need to look at powers of 2/3. If you start to look at powers of 2/3 and compare them to 1/9, let's see. So if I try to say, what happens if I do with cubed? Let's try that to start with. If I do 2/3 cubed, then I get 8/27. that doesn't look like quite enough because, for example, 8 over 27 almost looks like 1/3. Let's try another one that's even bigger. What if I do 2/3 to the power 6? This becomes 2 to the 6th, which is 64, divided by 3 to the 6th, which is 729. If I want to compare this against 1 over 9, let's see. How does this compare against 1 over 9? The best way to compare these types of fractions is to imagine that you multiply across. And if I take 9 times 64, 9 times 64 is definitely less than 10 times 64. And so this is going to be less than 640. And if I multiply this way, it's 729. And so I know that this is indeed less. Let's put that here. Good. So I know that I won't have to do anything bigger than this. So now let's try some smaller numbers just to see when is the first time that I pass 1 over 9. What other powers of 2/3 do I have? Let's try 2/3 to the 4th power, because here I did 3rd power already. 2/3 to the 4th power is 16 over 81. How does that compare to 1 over 9? Well, 16 times 5 is 80. That's around 1/5. This is actually still bigger than 1 over 9. How about 2/3 to the 5th? 2/3 to the 5th is 32 over 243. That is the 5th power of 3. How does that compare against 1 over 9? Let's try. If I multiply 9 times 32, that's going to be 320 minus 32, which is actually still quite large. 320 minus 32 is 320 minus 32 is going to be, let's try, 320 minus 32 is 10 minus 2 is 8. 1 minus 3 is 8. 288. So at that point, what I see is this would be 288. That would be 243. And the other one would be 243. And so this thing tells me that it goes greater in this way. So now what I've figured out is that actually this 6th right here, when n equals 6, this is exactly when I have that 1/9 is bigger than it. So my answer is, I wanted to know when is the first n for which this is true, and then that concludes that in this entire problem, the moment at which I have more than 4/7 raisins is actually right after I finish pouring on the 6th day. This question may have looked complicated. And what it shows is it shows that sometimes you actually can't do a problem just by brute force calculation. Because if you actually tried to do this by just adding all of the fractions together, it wouldn't work very well. If you imagine what sort of numbers you have when you have these 6th powers and 5th powers, the denominators are rather awful. And so it helps to know what kind of structure you can use instead. In this case, it's the geometric series.